Welcome boys and girls into my house again, and today we are going to do another experiment, and this time we are going to find out about some fuels. So we've been learning about energy, and we said that energy is the ability to do work. Remember, energy is the ability to do work. That's a simple definition. So we know that there are two types of energy. The one type of energy we call kinetic energy, and that is the energy of movement. So things like jumping and talking and singing and all those movements, playing tennis and kicking balls, that is all kinetic energy. The other type of energy is potential energy. Potential energy. And that is energy that is stored. So we have some examples of things that are storing energy. And today we are going to look at that, and we are going to see how much energy is stored in different products. So let's first have a look at the difference between kinetic and potential energy. Right, so here I have an apple. If I eat this apple, then I will get the energy. And that energy then I will be able to use. So we say the apple is stored energy, or the potato is also stored. So look at the spelling of potential and potato. They both start with the same three letters. That helps you to remember the difference between potential energy, stored energy, and kinetic energy. Here is kinetic energy. That is the energy of movement. I'm going to show you some movement here. This is kinetic energy. Watch my little worm. Oh, he wants apple. Oh no, he needs potato today. So his crawling is kinetic energy. He is moving, he is spending energy. Whoops, there's my crawling little worm. So that little worm, he is showing kinetic energy. Another form of potential energy, of course, batteries. You've seen these batteries, the energy is stored in that, and you can put it in your torch and you can get light, or you put it in your phone and you get sound, or we can even use it sometimes to heat things up. So we get three types of outputs. Outputs, remember that word? Outputs from when we are taking the energy out of potential and we are releasing that energy. So today our experiment is all about that, releasing energy. Okay. Right, so what we're going to do is we're going to test various stored energy to find out how much stored energy is in each one. Now that's a problem. How do you know how much energy is in it? So we're going to do it in an indirect way. We're going to burn it, and we're going to allow it to heat up some water. So I want to explain to you my equipment here. Here I have a fuel supporter. There's a little tweezers, and we're going to put the different pieces of fuel in there, and then we're going to light them. Then I'm going to put this big tin. Can you see I've taken the bottom out and I've made some holes in the bottom so air can go in, and I'm going to put it over the fuel which will be in there. I have a spike and a little tin, and I'm going to put the spike into the little tin so I can suspend it over the fire. And into the tin, I'm going to put 100 milliliters of water. Then I have a thermometer, and I'm going to measure the temperature and see how it changes. And that's the amount of energy that will have been released from the fuel. Will go and it will translate into heat in the water. So that's what we're going to measure. The temperature of the water when we start, the temperature of the water when the fuel has burned out. We're also going to time the fuel to see how long it takes for it to burn out. So those are the equipments that I've used. The knife I've put here because I had to cut small pieces of the fuel, and I also am going to use my cell phone as the timer. All right, so that's going to be our equipment. So here's the material, and these are the things that we are going to test, the stored energy in fuels. The first one are peanuts. So there are the peanuts. We're going to take one peanut, and I'm just going to collect our fuel already straight away. We're going to use one of the peanuts. Then we're going to do some wood. I had to cut a little piece of wood, peanut-sized piece of wood, and I will put it in there. And then we've got some coal. Now, the book tells you to use coal, but I know that coal doesn't work so well, but we're going to try it nevertheless. All right, and then we're going to do some biscuit. So I've got a peanut-sized piece of biscuit there, and last of all, a fire lighter. So I've got a little piece of these fire lighters that burn very nicely, and so we're going to do them on those 5 things. So there are our samples ready, and the last thing that I've got is the water, because that's what we're going to have to put in to our can to see how it warms up. So we're going to put 100 milliliters of water into our jar, our small tin, and we're going to measure the temperature, the starting temperature. Then we're going to light our fuel, and then we are going to monitor it and see how long it takes to burn up. All right, are we ready to do this experiment? So I've got my 100 milliliters of water in there. I have the peanut now set ready for us to light it, and I'm going to light it with a fire lighter. And then I'm going to put this with the water over the peanut. So let's first start with our water. So we've got to get our starting temperature. So I'm going to pour this water into our little can here. There we go, 100 milliliters. And then I'm going to put the thermometer in there, and we're going to get a quick reading. Nice chilly evening, but it's giving us 16 degrees, and we're now going to suspend it in over the tin. It's burning me.
It's not catching.
No. Now we've got fire. Oh, don't go out, fire. All right, got the timer going. And it's burning nicely. I can see it in there, the reflection. And we're going to stir. Our water started at 16 degrees. Now it's back on track. Also going on, now it's very nicely. 19 degrees. You can see that's how the good lights are shining around the outside. Oh, we're going to 20 now. Very nice contrast. Oh, 2 minutes. Energy. 22 minutes. Start to fade. Maybe we've used it up. 23 now. Let's check. It's all burned up. Oh, yes. You see that little wisp of smoke? You can stop it there. Good. So we've now changed it from 16 degrees to 23 degrees. So that's given us 7 degrees, and the minutes, it was 2 and 33 seconds. Almost 34. Fantastic. All right, so now we've released all the energy from that, and let's look at our little peanut. It's now just a ball of black fluff. Look at that. Just black. It's carbon. It's all burnt. So our next sample is wood. I've measured off the 100 milliliters in here, and I'm going to put it into the little tin, and we'll take the temperature of that water, which I've just measured in the big jar, so it should be the same, and it should be the same as what we started with before. Yes, we are on 16 degrees, and so we're going to start now with lighting our wood. Let's hope the wood burns quicker than the peanut. Yes, we've got a fire started. We're going to start the camera. The stopwatch. Is this burning? Yes. Very faint little burn. Give it a little start. Okay. Let's see how much good energy is for wood. Oh, it smells good. It smells good. Oh, no, so 17. Oh, that's very nice. I'm just trying to keep it enough, and I can see a little bit. Ah, let's have it. It's all burnt up. That's good. That's how it feels. All burnt, nothing left. I'll just catch the last glow. Yeah, we're on 18 degrees, so that was not very much, was it? And how many? 1 minute and 36 seconds. Let's check that temperature. Yeah, just making 18. Well, the wood is still glowing, so I don't want to touch it, but I would like to show you that there's actually nothing left in that, just carbon as well. Oopsie. No, it's a little bit hot still, but it's just a black ball of carbon, so our fuel has been burned up and we can get rid of that one. Okay, so we're going to the coal now. We've got 100 milliliters of water. I'm pouring it into the small can, and now we are ready to try and light this coal. So we're going to give this a few bashes, and if we can't get it to light, we're going to have to give this a miss, boys and girls. I'm sorry. We don't always have much success with coal. Oh, we've got a bit of a glow here. My finger is burning. It's a problem to get the coal to catch a light. It's trying to glow on this one side. I don't know if you can see there. Just a little bit on this side, there's a bit of a glow. But coal doesn't really burn with a flame, it does just glow. Right, so now we're going to put the fire lighter in the place of the coal. So in your table you'll see there's place there for the coal, but you're just going to cross it out and put fire lighter. So we've taken a little peanut sized piece of the fire lighter, and now I'm going to put the water into the jar so we can get started and take the temperature. It was 16 in there. Let's see if it's 16 in here. Yep, we're on 16. So let's light our fire lighter and let's hope this is more successful. There we go. Start the timer. We've got a good glow here. And stir. It's going up. Can you see nice glow? Nice. Okay. Now 18 already. 22. That's going fast. There's lots of energy in this fire, so it makes sense to use it to start fire. 25. 29. 32. 35. Oh, we're at 40. Oh, it's still going strong. 42 and a half. The light is starting to fade. Will we get to 45? No, 44. I think we have just about time. Right, so we are on 40. Let's say 45. It's so close to 45. 45 degrees. Yo, that gave us nearly 30s, 29. And that was the... in 2 minutes and 31 seconds. Good shot. So let's just see what's left of this fire lighter. Can you see it's all like fluffy? It's still a little bit of a glow. That's why I don't want to touch it with my fingers. But it's just fluffy, nothing. So everything was burned up. Okay, so we're going to start again with our next 100 milliliters of water. We'll take the temperature. Yeah, we've got it on 16. So let's see if we can get our biscuit to catch a light and how much fuel it can release. Is that burning? Yes, that's burning. All right. Okay, good go. That is 17 and 18. It's burning. 19. Let's just see, there's still some flame in here. That can cover burnt out everything that was to go with it there. 19 years, there we go. Now we're 20. Here comes the puff of smoke. I'll just check that it's all oopsie. Fell right out. Not much left going there. Still in. So our final temperature is 20 degrees. So we are now going to take our data and we're going to put it into a graph. So we're going to draw a line graph for each one of these, and we're going to see which one has stored the most energy. Thank you, boys and girls. We're going to continue in class or on your pages that you've got to fill in. Thank you.